first, let's start with Ramu. Can you say a few words about you and how are you doing today?
Yes, definitely. So I'm doing great. Thank you for asking, Karen. My name is Ramu. I'm a product manager for Spatial and Graph. I am currently located in Florida, but I'm originally from Spain, and I'm very excited to be presenting for you guys today.
Perfect. Thanks a lot, Ramu. My name is Karen. I'm a product manager for Oracle Spatial and Graph Technologies too. I'm based in Germany and specifically help our European customers and partners with their spatial and graph-related projects. We have some more team members who have joined the session. They will help us to answer your questions as we go along. We will start with a short intro on what Oracle Spatial is about, followed by an overview of Oracle Spatial Studio and how to get started with it. Ramu will then demo a typical spatial data processing workflow using Spatial Studio. And since we constantly add new features to Spatial Studio, we have also prepared information about the latest version, which is 22.3, and which was released recently. And of course, Ramu will show you some of the 22.3 features live as well. Okay, so what is Oracle Spatial? Many people associate Oracle Spatial with the database spatial capabilities, but our spatial offering is actually much broader. It consists of three major parts. The first is, of course, as I said it already, the core spatial functionality and support in the Oracle database. It allows you to deal with geospatial data using the Oracle database multimodal capabilities, from the locations of stores and customers to street networks, satellite images, or 3D city models derived from laser scans. You can store, manage, and analyze it all right in the database. And the most important fact is that you can do it together with your other business data. The second part you can see in the middle is comprises several software components, APIs, and services that make it simpler for developers to build spatial applications. These components enable you as a programmer to use the programming language or framework of your choice, be it SQL, Java, Python, JavaScript, REST, just to name a few. And you can do things like visualizing maps, you can turn addresses into coordinates, a feature that is called geocoding, or you can perform advanced analytics, such as route calculations, and so on. Some of these components, like the routing engine or J2E applications, that run on an application server. But from a licensing perspective, they can be used for free based on an existing Oracle database license or based on Oracle Cloud subscriptions. The last part you can see here on the right side has actually been a real game changer for us. It's a self-service tool we call Spatial Studio, and its purpose is to make it easier than ever for non-experts to get started working with and understanding spatial data. On the one hand, it is designed for analysts to perform spatial analysis and create interactive maps. On the other hand, it helps developers to create spatial applications and process workflows more quickly. As you can see here on the slides, part of our offering is also a variety of development tools and frameworks, the integration with platform and software services in the Oracle Cloud, the support for many programming languages, and the already mentioned J2E components for several spatial services. We could add more items to each list, but the space on a slide is restricted, as you probably have experienced yourself already. So let's have a closer look at Spatial Studio and why it is so essential. For over 25 years, we have had compelling spatial features in the Oracle database. Working with many of these features traditionally involved a certain amount of coding. You had to have at least some technical expertise to understand and use the features. When Spatial Studio was first released, all that changed because Spatial Studio simplifies the spatial data handling and turns a processing or analytical workflow into self-service operations. On the one hand, we have automated things as far as possible. On the other hand, we offer a graphical user interface that hides the specifics of geospatial data and spatial functions or procedures. For example, Ramu will show you how you can access spatial analysis operations in the database without knowing the SQL syntax. Again, making it easy for non-experts to perform these tasks is the purpose of Spatial Studio. Spatial Studio's easy-to-use approach supports typical spatial data processing workflows from data ingestion, preparation and enrichment, to interactive map exploration, to the actual spatial and also non-spatial analysis, to the publication of results. That's how you can integrate spatial analysis into more comprehensive workflows or make it part of larger applications. Let me give you a few more facts. So we've already learned Spatial Studio has an intuitive browser-based declarative user interface. It is designed to enable especially analysts and non-technical users to start placing and showing location-based information on maps and perform spatial analysis without writing a single line of code. It helps to master the hundreds of spatial operators and functions available in the Oracle database, and it renders data sets and analysis results as maps in order to put them into context. And of course, it can hand off everything you create to other cloud services or applications such as Oracle Analytics Cloud. With Spatial Studio, you can convert address data into coordinates that can be also displayed on maps. This conversion is done using a background service called Oracle Maps Cloud Service, which relies on reference data provided by a company called here. And remember, all this comes free of charge with Spatial Studio. Let's look at some examples of how Spatial Studio works. The spatial features in the database offer support for all relevant types of geospatial data. Spatial operators and functions can validate, filter, categorize, aggregate, enrich, measure, or modify data. Spatial data can be simply geometric data, as you can see here, like point geometries representing schools, line geometries representing roads, or polygons representing major fire zones. Based on this data, you can analyze, for example, which schools in Northern California are near major fire zones, so the local communities can establish action plans and decide on evacuation routes in the event of an active fire. This is just one example of a spatial analysis that you can do. Whatever kind of analysis or data manipulation is needed, the fundamental idea is always the same. The database provides what we call the plumbing, the basic functionalities for dealing with spatial data, so that an analyst or database developer can focus on the business logic and doesn't have to reinvent the wheel over and over again. Among the more advanced features that we offer, we have what is known as a network data model. It includes a storage model for networks such as road networks, rail networks, or utility networks, and it enables a developer to perform calculations that take into account the network's connectivity and its constraints. This could be a shortest path calculation, a traveling salesman optimization on a road network, or computations to determine which households would lose power when a power line is destroyed in a storm. We also support streaming data, which you typically find when working with GPS devices or IoT sensors that constantly transmit position information, or what we also call location data. We can ingest streaming data, for example, through message queues, and we provide built-in functions for location-based tracking and tracing. A very popular, well-known use case related to this is raising alerts in real time when a non-authorized object is approaching or entering a protected zone, or if a vehicle has a certain distance from a given destination. And what we are also familiar with is an out-of-the-box functionality we have implemented in the Oracle database, which is used to perform contact tracing. You probably all remember almost 3 years back at the beginning of the COVID-19 pandemic, we needed solutions that helped us to detect when and where somebody was in contact with an infected person for long enough to get the infection her or himself too. Some customers use our technologies to manage, analyze, and visualize satellite imagery or area images taken from drones or airplanes. Mostly, these customers are or have specialists using geographic information systems, or GIS for short, together with Oracle Spatial. They typically use the database for large-scale processing, whether it be for geometric correction of distortions of the images, which is required to correctly fit them onto a map, or whether it be for the purpose of analytics, for example, the computation of the vegetation index for every pixel in the image. As you can see here, Spatial Studio can visualize these pictures, and this does not only work for images, you can use the same functionality also for other regular grids, which you can find in thematic mapping especially, where you would be graphically rendering, for example, meteorological data, such as a predicted temperature, or displaying demographic data like income levels. Beside raster images, you can also use our support for three-dimensional data. Since the cost of three-dimensional data collection has gone down significantly in the recent years, it has led to huge volumes of data being collected from buildings, building interiors, or entire cities. This makes it increasingly challenging for anybody to cope with the sheer amount of data. In Oracle Spatial, we can store and manage the specific kinds of data in this domain too, which are 3D solids, terrain models, laser scanning data typically. And all those together with the associated metadata and attribute information in order to enable fast access to the relevant parts of these kind of data sets and to do scalable processing. As you can see here, you can use Spatial Studio to visualize 3D data as well. The screenshot here shows a 3D model of buildings in New York City. And that said, working with 3D city models or detailed digital twins, you would typically use specialized 3D third-party tools in order to render, annotate, or manipulate the data. So that was enough talking from my side. Let's switch over to Ramu for a first live demo of what Oracle Spatial Studio is about and to give us a first hands-on experience with it.
Awesome.
Ramu, will you please take over?
Yes. Thank you so
Thanks.
much, Karine. So as Karine said, we're going to do a quick demo on how Spatial Studio works overall. So we'll start by loading our data, then we'll create a project, style our map while we're going through the demo, perform some analysis, and we'll learn how to share our project in case we're working with a teammate or someone in the same project. So let's go ahead and start by using our Spatial Studio credentials to sign in. And this is our landing page for Spatial Studio. So we'll start by uploading data into our Spatial Studio instance. So we'll go to our Datasets tab and click on Create Dataset. And we'll be uploading data from a file. So let's go ahead and click on the tile, and we'll be uploading a GeoJSON dataset. In this case, this dataset contains information on accidents that happen in South Africa. And the first thing that we're going to be asked to do is select our connection. So in this case, I'm going to use an autonomous database connection, and I use my wallet to connect this instance to my autonomous database. And we also get a preview of our data set, and it also gives us a chance to change our data types. So in this case, I want to keep everything the same, but I'm going to change the vehicle data type from string to numeric. And I'm going to go ahead and click submit. And as you can see in here, I already have some data sets uploaded, but as soon as the upload process is done, we're able to see our accidents data set, and it is showing a warning sign for us, meaning that we might have to perform a little more preparation for our data set to be ready to visualize. So we click in the warning icon, and it tells us that we're missing a key column. So in general, you're able to visualize your data set in a map if you want to without a key column. But since we're performing some analysis, we're going to go ahead and add that key column. So let's go ahead and click on Go to Dataset Columns. And since I'm familiarized with this data set, I know that there's not a column that I want to use as a key in this case. So we're going to click on Create Key Column. And we can do this just by clicking there and adding a column ID name and click OK. And Spatial Studio allows us to generate that key column in less than 1 second, basically. We'll go ahead and click Apply. And we got rid of that warning sign. So let's go ahead and create a project with that data set. We'll click on the 3 dots and click on Create Project. And here we have our map. Under datasets, we're able to see our accidents dataset. And let's drag and drop this. And here we have our accidents data points. And as you can see in here, our accidents dataset has moved into the layers list for our visualizations. So let's go ahead and save our project really quick before we move on. And we're going to call it Spatial Studio Intro. Okay, so just to make sure that our project was saved correctly, we're going to go into our Projects tab, and we're able to see it right here. So we did everything okay. Let's go ahead and start basically styling our map. So to do that, we can click on the 3 dots, select Settings, and there's different styles to render our data set in here. So to do this, for example, let's take a look at heat map. And the heat map basically shows us how we have different places where our accidents are concentrated. So for example, we can see that the red shows us that there's a lot of accidents happening in this area of our map, but the cooler colors show us that we might have less accidents in these areas. Another cool visualization is clustering. So clustering is basically numerous points clustered in an area. So if we zoom out, we're able to see how our clustered numbers are bigger compared to if we zoom in. we are able to see the number of accidents a little more in detail. So let's go ahead and perform some analysis. And to do this, I'm just going to turn back my data points into circles. And I want my circles to, since they're representing accidents, I want them to be red. And let's go ahead and add more data sets into our visualization. So add data sets, and I want to add police bounds that are basically the geographical areas patrolled by stations. And I'm going to add police points that are the police stations in those areas. So let's go ahead and drag them to our visualization. And as you can see in here, we have 3 layers instead of 1. But it's a little hard for us to visualize our accident points. So what we can do is we can drag our police bound to the bottom to be able to see those points better. So let's go ahead and change our police points to be shown as symbols. So again, we go to render style and we click on symbols. And let's pick a symbol that is associated with police or police station. So we do have a lot of symbols, so you can personalize as you wish. But I'm going to pick the police symbol and I'm going to change the color to blue. And let's make our layer, our police bound layer, maybe red, but change the opacity to make it a little more transparent to be able to see our data points a little better. So let's start by creating an analysis for filtering by proximity. So in this case, let's say that we want to look for accidents that are within a distance of our police station. So I'm going to pick this police station. So if I zoom in, you're able to see that I selected this police station because it has a red circle surrounding that police station. And then we're going to filter by accidents. So we'll click on accidents and click on spatial analysis. And then we want to return shapes within a specific distance of another. So we'll click on this analysis and it allows us to give our analysis a name. So let's say that we want it to be called accidents within distance of a specific police station. So within a police station. And the layer to be used as a filter is police points. And this is enabled because we wanted to show the accidents that are within the specific selection that we already selected, that was a specific police station. Let's set the distance to 30 kilometers from that police station and hit run. So something that we're allowed to do with our layers is we're allowed to disable that layer. So in this case, we're disabling the accidents layer because we want to drag just the accidents that are within 30 kilometers from that police station. And as you can see in here, this analysis returned those accidents. And I also want to point out that we're basically creating a data set with those data points available that we can use anytime. Let's say that we don't need this analysis anymore. We can go ahead and remove it from our layers. And now we want to maybe create an analysis that shows a summary by region. So a summary of accidents per region. We can go ahead and maybe disable police points, and let's keep the region for now. So we can go into our regions or police bounds data set, and click on Spatial Analysis. And in this case, we're going to use the Analytics tab and click on Summarize by Region. And we want to summarize by region depending on the number of accidents. So the summarized item is going to be accidents, and we want the summary to be count, and we want the accidents count. So accidents count. We click Run. And again, we're going to create another data set with this analysis. So let's go ahead and drag this analysis into our map. And let's disable the police bound layer. And I know that this is not giving us a lot of information, but let's say that we go into our settings and change the color to be based on data. We want that color to be based on the accidents count data. And right now, because of the values, we cannot see a lot of the different colors. So we want to adjust those values. So my minimum value is going to start at 1 maybe, and we want it to be a maximum value of 20. So generate bins values, and we see how our colors have changed, showing that, for example, the darker the red is, the more accidents we have in that police bound. Another way of also visualizing our data would be in tables. So let's say that we want our map view, but we also want to view our data in a table right next to our map. We can go ahead and go to visualizations and drag our table and click on data and drag our analysis into our table view. And it will give us a table view for that data. So if we don't want this anymore, we can go ahead and delete it. And another really cool thing about the analysis is that we can actually access SQL code and GeoJSON endpoints. So if you're a developer, you might be interested in accessing results programmatically. So to do that, we can go ahead and go back to our police bound summary, for example, click on the 3 dots and go to Properties. And here is where our SQL code is available. So if we wanted to run this in SQL Developer, we're able to do that. Or we can have the access to a GeoJSON endpoint and have our data as in GeoJSON format. So if we go into our browser and we paste this URL, we are able to access this data as a GeoJSON format. So now that we're happy with the results of our analysis, let's say that I wanted to share my results with Karim, right? We would go ahead and save this, go to Actions, and publish our project. So let's go ahead and publish our project. And now that our project is shared, we go back to Projects and click on the 3 dots and click on URL. And we can copy this URL and send it to Karim for her to access our results. So she will be able to just copy and paste it in a browser, and she'll have access to the layers I've used to visualize my results. So this concludes the demo for basically how to use Spatial Studio. We do have a lot of other functionalities, but I'm going to pass it on to Karim that will go over the new features of Spatial Studio 22.3.
Okay, perfect. Thanks a lot, Ramu.
Of course.
Okay, so you should be seeing my screen or again with the slide for the live demo.
Yes.
Okay, just a second. Okay, perfect. So let's go ahead. We promised to have a special look at the new features of Spatial Studio 22.3, which is the newest version. And let's see what we have as major features added to this new version. So the first feature is creating of custom regions. So here a group of existing regions or data sets may be combined into custom regions. Spatial Studio now streamlines this process by automatically creating a new table and a data set for these custom regions. So this is the first one. And Ramu is going to show you this right after the slides. The second feature lets you create data sets from so-called OGC web map services. What is OGC? OGC is the standardization group for publishing of spatial data information or defining spatial data. And the web map service gives access to a standardized web service that provides spatial data as image information. And you can use now these kind of data sets as layers in your map. Previously, Spatial Studio already supported web map services, but only as so-called base maps. So the underlying map you use to display the layers on top of this. This could already be a web map service, but now the layers itself can be web map services as well. The third feature we want to talk about is that you can create now data sets by dropping pins on a map and saving those. And these saved pins can then be used like any other data set for visualization and also for analysis. And the last new feature is that you can define multiple criteria also for non-spatial filter analysis. You can define spatial multiple criteria to be used as filters in a non-spatial analysis. And rather than explaining the features verbally, let's Ramu take over and show them live.
Okay, so let's go ahead and share my screen again. And we are back in Spatial Studio. So in here, I already have a data set showing different Texas regions. And we're going to start by creating a custom region that is now streamlined. So this means that you can automatically create a new table and data set from a custom region in Spatial Studio. So let's say that I wanted to divide my Texas regions between South and North. To do that, we can use the selection tool in Spatial Studio and drag this tool to select the specific regions we want. You can also do this manually, but it's easier to use just the selection tool. So if we click on the light bulb, that is the actions tool, there's a option that says create custom regions. So we're going to go ahead and select this. And we want the target data set to be new, because this is something that we're starting from zero, right? We don't have any other Texas regions. We're going to give our table a name. So in this case, I just want to call it Texas regions. And I'm going to give my data set the same name, Texas regions. Then it's basically asking me to add a key column name. So this would just be our unique identifier of the column. And a key value, it can be a number or it can be a string. In this case, I'm just going to name it North Texas. And we're just going to click OK. Okay, so it looks like we've created our custom region successfully. Let's go ahead and add this to our data set. So we'll be able to find this custom region under datasets right here. Let's click OK. And let's drag and drop it to make sure that everything looks good. And here we have our South region. Let's go ahead and create our North region now. So again, we're going to use a selection tool and drag across it. And let's deselect our North region. And we would go back to the light bulb. Again, click on Create Custom Region. And in this case, we're going to use actually the Append to Existing option because we already have this region created, right? This Texas regions dataset created. And we select Texas regions and enter new shape attributes. And this is just asking us for the region ID. So before we entered North Texas, now we're going to enter South Texas for our region ID. And then let's click OK. And OK. Again, and Spatial Studio is just refreshing since we have this layer already in, well, since we have this data set under layers. And this might take a little bit of time. But basically, the really cool thing about this is that you can save these custom regions and use them in the future for analysis purposes. So let's go ahead and make our visualization a little bit more interactive. So let's go to Settings. And if we click on the Configuration menu and select Interactions, I want to see the region ID every time that I hover over it. So we enable tooltips and region ID, and every time that we hover over it, we'll be able to see our custom ID. So another feature that Karine just spoke about was the saving our pins, right? So let's disable this layer for now and enable back just the Texas regions overall. Let's say that I was looking at different regions of Texas, right? And I was just dropping a couple of pins to remind myself where to go back when looking at this data set. But basically before, we weren't able to save this pinpoints, right? But now we're able to by just going to Actions, Save Points. And let's say that I just want to name my points just pinpoint places or pin places. Let's click and run. And for some reason, I'm done with my pins. I can just go ahead and click on the Clear menu and click on Clear Pins and come back to wherever I put those pins in the future by looking into my analysis and pinpoint places. So if I drag and drop this just basically shows a data set with those pinned places. So again, you can use this for future analysis. Another feature that we discussed was the non-spatial filtered by multiple criteria. So let's go ahead and add our accidents data set again to show you really quick how we're able to use this multiple criteria as an example. So we're going to go back to South Africa by zooming back in this layer. And we have our accidents data set again in here. And we want to create a non-spatial filter with multiple criteria. So to do this, we're going to click in the three dots for accidents and click on spatial analysis. And under filters, we have return elements filtered by non-spatial rules. So let's say that we wanted to filter our data set by the column of severity, the equal to 3. So we only want to see accidents with severity value of 3. And we want to add another criteria, we are able to say and or. In this case, I'm going to say and, because I want the number of vehicles involved in this accident to be greater than 6, for example. We go ahead and click run. And let's disable this layer for now and use our accidents filter. And it should only be showing us accidents that had severity 3 and involved more than 6 vehicles. So to double check this, let's go ahead and visualize our data in a table. So looking at this table, we're able to see how all of the accidents were severity number 3 and it involved more than 6 vehicles. Lastly, I want to go ahead and show you guys how to use the web map services. So creating a data set from web map services. So there's a prerequisite before doing this that is basically saving your domain under saved domains. And this is something that your admin will be doing. But let's go ahead and create a connection for the web map service that we're going to be using. And we would go to our connections tab and click on create connections, select OGC web map service and click next. So in this case, I've already done my research and I have a link with the URL that I want to use. And I'm going to give this a name. So this is basically from the National Oceanic and Atmospheric Administration, and it's just displaying data. So let's go ahead and click OK. And go back to our data sets, and we're creating a data set from this URL. We're creating a data set from the web map services, and it should show our connection that we just created in here. Let's click create, and this URL actually has 3 different data sets. You can create a combination of these data sets whenever you want to, since you already have it under connections, but I'm just going to use the image data set. And I'm just going to name it NOAA Weather Images. Click OK, and we should be able to see it under data sets and click on create project to visualize this layer. So previously, Spatial Studio was able to do this, but it only supported it as a base map. And now we're able to create a data set from this. And this is very useful if you want to add more meaning to your visualization by combining this with other data sets. And this basically concludes our demo for Spatial Studio 22.3 features. So I'm going to pass it on to Karine again for our conclusion.
Okay, thanks a lot, Ramu. Let me share my screen again. So we will be back. Okay, perfect. Okay, so let us recap what added value you can get from Spatial Studio. So you've already seen Spatial Studio is a free web-based tool to be used with the Oracle database, either in the cloud or on premises. So you can install it in your own environment, or you can use the different choices you have using the Oracle cloud. Spatial Studio makes it easy to explore, process, and analyze spatial data visually. And combining the capabilities with Spatial Studio with those of other tools and techniques gives you plenty of possibilities to take any analysis of enterprise data to the next level. Okay, so this is what we've prepared for today to talk about Spatial Studio. I have a few more complementary information which I would like to add after the Q&A. Now I want to look at the Q&A part of Zoom, and as I can see, there are a few questions that have already been answered. Okay, any other question? Does Spatial Studio run from Windows or Linux? Yes, it does, from both. So you can install it on Windows, you can install it on Linux, and as far as I know, also on your Mac. Any other questions? Not? Okay. You still have time to put your questions. Okay, database versions. I assume the question is which database versions are supported for Spatial Studio. All database versions starting from 12.1 should be supported. David, is that correct?
Yeah, so officially we're listing 19, but 12.2 should work.
Okay.
But the official, the official message is 19, but again, like 12.2 would be your practical minimum.
Okay. It's also from the support perspective, it's better, or it's time to migrate or upgrade to 19C if you can. So does Spatial Studio need a JT server component to be installed? It does not need an application server. It can come, or you can also download a so-called Quick Start kit that has a tiny application server embedded. But of course, you can also deploy Spatial Studio on an application server.
Yeah, just to be about that. So yeah, it's a JE application, so it runs in JE server, like Karen said. The lightweight option is this pre-bundled, pre-configured quick start that is Spatial Studio deployed in a Jetty server. So you just unzip it and run it. That's actually what you get if you install Spatial Studio on the cloud marketplace. You can also download a Spatial Studio deployment for WebLogic server. And Spatial Studio can also be deployed to Tomcat. And if that's something that's important to you, then you would contact us and we could speak more about that. But off the shelf, it's a pre-bundled Jetty deployment or a WebLogic server deployment that you can perform.
Okay, thanks a lot. And I think there was one more question. Hans has already answered. Okay, perfect. So feel free to put more questions into this section as we present the last parts for today. So let me go ahead with that. So here is some information about what we have already discussed and you were asking for. So you can run Spatial Studio on premises on Windows or Linux or Mac machine. And there are two options. Basically, you can either use this Quick Start kit or bundle David has spoken about, and just unzip it, or you deploy it as an EFI on either WebLogic or Tomcat. With regard to the options to run it in the Oracle Cloud, you just download it from Oracle Technology Network and install it on a compute instance. This is the second option you can see down here. Or the first and easier option is to just deploy it directly from the Oracle Marketplace. And then there is a stack created and you can run the Terraform stack to set up the required resources. We can learn more about Spatial Studio, I've put together here a few general information about Oracle Spatial Database. So this is the URL to get started with spatial technologies. You might be familiar with Oracle Live Labs, where you have a bunch of workshops with step-by-step tutorials to do fancy things with the Oracle database and other Oracle technologies and services. And we have also included workshops that are related to the spatial technologies. The documentation you can find here about Oracle Spatial Studio. And then you also might have heard that we have something called Oracle Reference Architecture Center. This is where you can find information about how to set up the several components that form an application or a solution you might be interested in. And there we have created a reference architecture to build a geospatial platform using the Oracle Autonomous Database. We also have several blog posts I can recommend. The first blog you can see here is actually our legacy blog. We used to post technical content there until early last year. Nowadays, we have joined the Database Insiders team to post our spatial content related to spatial also there, and you can just find it under the tag spatial. We also publish technical posts on medium.com. Just watch out for the tag Oracle Spatial. And of course, we do publish videos on YouTube. There is a special channel called Oracle Spatial and Oracle Graph, where you can find information. Maybe everybody, please mute. There's somebody who has muted him or herself. Okay, and if you want to follow up with newest information on Twitter, just watch where we are. Here are Twitter handles of some of the colleagues in our team. Just to follow us so you are up to date with newest information about spatial and also graph technologies. Okay. It's the end of our session. We've prepared already the next session, and as this session today, the next session we will also you have some kind of introductory session where we talk about fundamental techniques using spatial, and the sessions afterwards, those will go into more details, picking specific topics we would like to talk about with you. The next session you can see here is planned for February 14th. We would love to see you all back and many more to join the next session. For now, I wish you a nice rest of the day wherever you are, and see you soon.
Thank you, everyone. Have a good day.